Good evening, everyone. Welcome to Grow Up Online Choices and welcome to the class of Ncert Line to Line explanation of Haloalkanes and Haloarenes. In the previous videos, in part 1 and part 2, this is the part 3. In part 1, we discuss about the cluster clear explanation of haloalkanes introduction. And in part 2, we discuss about the classification of haloalkanes and haloarenes. If you missed that videos, please go to the playlist of Grow Up Online Choices and where you can find out that haloalkanes and haloarenes in English. Okay, I suggest you that please see the first and second videos and come to this video if you are new to this channel. Okay, now let us jump into the today's topic, that is the most important one, that is nomenclature. So simply what does meant by nomenclature? So the nomenclature, which means simply naming, naming the given compound, naming the given compound. So we understand that nomenclature, which means naming the given compound, given organic compound, simply given organic compound. You have to name the given organic compound in a fixed manner, that we call the nomenclature. Now let us try to understand how to name the given organic compounds according to haloalkanes and haloarenes. Now let us try to understand the concept of nomenclature. So we simply understand that the nomenclature means naming of naming the given organic compound. So simply understand that giving the organic compound. Okay, naming the given organic compound. Okay, we have some set of rules. So we have the some set of rules, that is IUPAC nomenclature. Sir, what's the need of this nomenclature for the given compound? That in organic compound, we observe that different compounds are present. If you name by different types, for example, if the source from where it is prepared and the scientist, we have a confusion that the given scientist, for example, here is the my name is Naidu, the Naidu's compound. What does mean by what does really mean by Naidu's compound? What does means by Naidu's compound? So we have thousands of millions of compounds are present. So for recognition for purpose and for identification purpose, it is very difficult where it is an obtaining. For example, if it is obtained from source is also very important. The discover scientist. So the overall concept is that you have to remember according to source and scientist is very difficult for us. That's why we come up with a good formula, that is IUPAC nomenclature. The IUPAC, which is we already know that International Union for Pure and Applied Chemistry. So according to this, we have to name the given compounds. Okay. Now let us try to understand the IUPAC format. Okay. Firstly, try to understand the IUPAC format. So the IUPAC format is prefix plus root word plus primary suffix. Here you have to know that you have to remember that in this class I am going to explain only according to how to name the given haloalkanes and haloarenes. I will promise you to that I will explain total IUPAC nomenclature within 1 week. I plan December 10. I plan December 10. It will take 2 hours time. So for this video, have to complete watch of this video. You have a full-fledged knowledge about the what does mean by impact compounds, and you have a cluster clear idea about the how to answer IUPAC nomenclature of times. But in this video, according to I will explain haloalkanes and haloarenes, how to name the haloalkanes and haloarenes. You have to point out that. Okay, this is the IUPAC format. What was the prefix plus root word plus primary suffix plus secondary suffix? Now let us try to understand each one clearly. What does mean by prefix? The prefix, which means methyl groups, the side substituent compounds, methyl group. So it is named as, if it is a substituent is CH3, so it is named as methyl. So next one is C2H5, then it will become ethyl. The halogen compounds are also present, so it is known as the chloro. So what does mean by root word? The root word which means the number of carbons. If the given carbon is 1, so we know that it name as Meet. If the number of carbons is 2, then it is Eet. If the number of carbons are 3, it will be becomes a prop. If you have doubt in that, if the number of 8, 9, please refer to the NCRT hydrocarbons lesson. Okay, it will better understanding. And third one proof, and fourth one is but, fifth one pent, and sixth one hex, and seventh one is sept, eighth one is oct, ninth one is nonane, and the tenth one is dodecane. Okay, here is the number of carbons means. Here primary suffix means. What does mean by primary suffix? Primary suffix indicates the bond between the carbon and carbon. If the bond between the carbon carbon is single bond, so it is named as an. If the bond between the carbon carbon is a double bond, so that will be called as ene. If the bond between the carbon carbon is a triple bond, that it is a hyne. If the bond within the compound, we have the possibility that both the double bond and triple bond is present, so we name as an ine. So the reference for a secondary double bond and triple bond, another one. Okay, and ine. So what does mean by primary suffix? The primary suffix which means functional group. It indicates the what is the functional group present in that given compound. So we have a lot of we have so many functional groups are present, but according to this lesson, we have the functional group haloalkanes and haloarenes are substituent are Cl. So suffix is secondary suffix is chloro. So its name is chloro. And we have the functional group OH. If the functional group is OH, we can easily indicate OL. So in the given compound, OL means OH functional group is present. Okay, if in case of aldehyde functional group is present, so we can write as AL. So this is the overall IUPAC format to write any IUPAC nomenclature for given organic compound. Here is the this format is used for to write the any organic compound for naming purpose. Now let us try to understand what was the concept present in our NCRT. I hope the primary understanding of what does mean by nomenclature. The nomenclature which means simply by naming the given organic compound. So according to IUPAC nomenclature, we have some format to name the given compounds according to IUPAC nomenclature for the given organic compounds. Now let us try to understand the examples of how to name the haloalkanes and haloarenes. I promise you to in December 10 it will take 2 hours or 2.5 hours. I will completely explain the IUPAC nomenclature. No doubt, undoubtedly. Okay, now without any question marks, I will explain. I will take previous year question paper roughly 100 to 200 questions. I will take after the class. Okay, I will promise you to that. And now let us try to understand the today's topic. What was present in the NCRT. Okay, having learned the classification of hallucinated compounds, let us now learn how these are named. So we previously discussed that in the second video we discussed about the classification of haloalkanes, and that the most important one allylic and vinylic groups. And next one, now let us try to how they are named. The common names of alkyl halides are derived from the naming of alkyl group followed by name of a halide. So simply we can write the, now let us try to understand this line by taking example. Here is the common name for the given organic compound. Here we observe that here one, two, three. We observe that this is a N-propyl means, N means straight chain, the number of straight chain. Here N means straight chain. Okay. So according to given concept, they explain that the name of common name, for the common name, we can observe that the straight line taken from the hydrocarbon part. It is taken from the alkyl group. Here we observe that CH3, CH2, CH3. Instead of CH3, we have CH2, CH3. This is the hydrocarbon. We name it as a profane. But the replacement of one hydrogen with bromine, so it will become CH2Br. So its name is N-propyl bromide. N-propyl bromide. Here also same to same. Here one, two, three. So we observe that iso. If the given groups are in this way, CH bond CH3 bond CH3. Whenever we observe this type of compounds, we can simply name it as iso. Simply name it as isopropyl. Why? Because three carbons are present. One, two, three. So its name is isopropyl. Isopropyl. So we observed that at chlorine attachment is there. That's why we name it as isopropyl chloride. And second one, and that last one is the here we have to observe that these are the common names which was naming naming depends upon the alkyl group followed by halide. So we observe that here is the first one. First ones are alkyl groups and second ones are halide ones. Okay. And the last one is here whenever I observe this type of group, functional group, this type of compound, so simply called as a isobutyl. Why? Because butyl means four carbon series. The one, two, three, and four. So total of a isobutyl chloride. So totally, so its name is common name is isobutyl chloride. But according to in the IUPAC system of nomenclature, alkyl halides are named as a halo substituted hydrocarbon. So this point is clearly explained that the halogens are these halogens are taken as an substituted ones. From monohalogen substituted derivatives of benzene, common and IUPAC names are same. For example, mono, that means single halogens are present. Single halogens, for me, mono means the single halogens are present in benzene derivatives. In benzene, the common and IUPAC names are same. So here is the example that here we observe that bromobenzene and the IUPAC name of this compound is also bromobenzene. So both are bromobenzenes. So we observe that common name and IUPAC names are also same. And next concept for dihalogen derivatives, the prefixes are the meta para are used in common system, but IUPAC system we use 1 comma 2, 1 comma 3, and 1 comma 4 and are used. So according to so we know that for example here is the benzene, here is the substituted one. Adjacent to substituted ones, these are ortho and these are meta, these are para ones. So according in common names, we use the ortho meta para ones, but according to IUPAC nomenclature, so adjacent position is 1, 2, 3, 4, 5. So we can simply, where the substituted ones are present, we can simply apply the numericals in IUPAC system. And in a common system, we can easily use the words ortho, meta, and para. Okay, here is the common system that here 1, 2, 3. That means ortho, meta, and para. At the para meta position, we observe that bromine is present. So M dibromobenzene. Why? Because two bromines are present. But according to IUPAC nomenclature, the naming are 1, 2, 3. One and at the first position, we observe that first position and third position also occupied by bromine. So we simply name as 1, comma 3 dibromobenzene. Now let us try to understand the last one. Here we observe that here 1, 2, 3, 4, 5, and 6. Its positions are ortho, meta, and para ones. So here we observe that symmetrical. Why? Because pass the plane, if you pass the plane, these two are mirror images to each other. If you pass the plane towards this line, these two are mirror images to each other. If you pass the plane towards this bromine, these two are mirror images to each other. That's why we use the word symmetrical. So this point is also important. Why they use the symmetrical? Why does not use the unsymmetrical? Why? Because here we observe that symmetrical means when you pass a line or plane. For example, now let us try to understand why symmetrical word is used before the common name. Here we observe that when you pass a line towards this, we observe that these two are mirror images. For example, here is the plane. So these two are mirror images to each other. If you pass the plane towards this bromine, these two are mirror images to each other. So when you pass the mirror images, when you pass the plane towards this bromine, so here is the number one, number two, and three. When you pass these planes, the two remaining two are mirror images to each other. That's why we use the word symmetrical. Now let us try to understand the positions. Now let us try to understand its positions. So here position is 1, 2, 3, 4, 5, 6, and the positions are in common name ortho, meta, and para. So symmetrical tribromo, that means one tribromo, simply tribromo benzene. But in IUPAC system at the first position and third position and fifth position occupies the bromines. So we call it as 1,3,5 tribromo benzene. I hope this concept is clear to you. How do you name in a straight chain is present in aromatic compounds? How do you name the given compounds? Okay, according to common names and according to IUPAC names. So here is the important point is that the common name and IUPAC name for this compound, that is bromobenzene, both the common names and IUPAC names are same in bromobenzene. I hope this concept is clear to you. Now let us try to understand the remaining questions. Okay, here is the applications of the given compounds. Now let us try to understand the given compounds. Here now let us back to the concept with that. So prefix, root word and primary suffix and secondary suffix. The important point is that whenever we consider this is an substituent, the substituent must be, the substituent must be in a low preference, must be in a low preference. That means the numbering should be given to that compounds are is low. Number is low. Okay, now let us try to understand what is mean by must be in a low preference. So okay, now let us try to numbering the given compounds. Why? Because we have to know the what does mean root words. We have to know the root words. Okay, here 1, 2, 3. Okay, this is the one, and here is the 1, 2, 3. So we have the two preferences are there. Here, top to bottom preference is there, left to right preference is there. What will be the most preferable one? What is the most preferable one? Why? Because the left to right is most preferable. Why? Because the chlorine attached carbon having the low number. This is the lowest locant number. Lowest. So this process is called the lowest locant rule. So the the substituent must get the lowest value. So the left to right preference is more preferable. So it's a number. Now let us try to understand its IUPAC name. Here 1, 2, 3. Okay. Here 1, 2, 3 carbons are present. Okay. Here we can observe that here 1, 2, 3. At the second position, two substituents are present. So at the first position, one chloro. So we started with at the first position one chloro. Why? Because this is according to the alphabetical. This is according to the alphabetical. So we observe that the one 2 comma 2 dimethyl. Di means di is D is after the C. That's why at the first position chlorine is present. So we can easily name it as a 1 chloro 2 comma 2 dimethyl propane. Okay, 2 comma 2 dimethyl propane. Why? Because propane means here we observe the single bonds are present. Propane means 3 carbons are present. 2 carbons are act as a dimethyl disubstituted. So now let us try to understand second one. Here is 1, 2, 3, and it is 1, 2, 3. We can write left to right or right to left. We can observe that the numbering for bromo substituted one is lowest from left to right or right to left. So we can simply 1, 2, 3, 3 bromines are present. That means proform. The position of bromo is second position. So 2 bromo propane. That means single bonds are present. That's why we use the N. I hope the IUPAC nomenclature concept is clear to you. In the next video, we will discuss about all the applications of IUPAC nomenclature, examples, and previous year question papers according to IUPAC nomenclature also with respect to haloalkanes and haloarenes. If you have any doubt in this class, please feel to contact us in WhatsApp or direct call. We are able to solve the given question, what we have the doubt. And please share with your friends and family members. Uh, Please share with your friends and family members those students who are really need this type of videos. I hope this video is clear to you.